Hey Ramblers! This video covers chapter 10.3, which deals with the arcs of a circle. Now an arc, as we've learned before, is just a portion of the circle. It's kind of, a fraction of the circumference. So there's a relationship between the arc and the chord and the central angle that intercepts the arc. And it's really pretty simple. If arcs are congruent, then the chords that intercept them are congruent, and the central angles that intercept them are congruent, and vice versa all the way. So if angles are congruent, arcs are congruent, and chords are congruent, and if chords are congruent, arcs are congruent, and angles are congruent. Anyway, let's go through this, the arcs of a circle, and we'll introduce you to some new vocabulary, show you a couple tutorials on how to do some of the problems, and make sure you pause often. I hope this helps, and thanks for watching. Okay, the arcs of a circle. As I've said, arcs consist of 2 points on a circle and all the points needed to connect them by a single path. So B and C are 2 endpoints of the arc, and all the points between B and C make up arc BC. Now P is the center of the circle. It's also the center of the arc, so it serves a dual role. Okay. There's 2 kinds of arcs that we'll be dealing with. The first is a minor arc. A minor arc is one that has its points are between the sides of a central angle. So in other words, all the points of arc BC are in the interior of the central angle P. Their measure is always less than 180. Major arcs are in the exterior of angle P, and we sometimes call them with 3 letters. So this might be named arc BDC, whereas the minor arc would just be arc BC. The measure of an arc is always going to be exactly the same as the measure of the central angle. Now, what is a central angle? Central angle is an angle whose vertex is at the center, hence the name, and its sides are made up of radii. So the measure of an arc will always be equal to the measure of the central angle. Now the measure of the major arc is always going to be equal to 360 minus the measure of the minor arc, which should make sense. Together, the major arc and the minor arc have to add up to 360. So subtracting the minor arc from 360 will give us the measure of the major arc. All right, now, congruent arcs, what are those? Well, if you looked at the measure of arc EF and you looked at the measure of arc BC, you would see that they are the same measure. They're the same fraction of the circle that they're on. But clearly, nobody would say that the length of EF and the length of BC were the same, nor would they say that EF is congruent to BC. So we have to look at the definition of congruent arcs. Congruent arcs have the same measure and they are parts of the same circle or congruent circles. You'll recall that the measure of a central angle and the measure of an arc are equal. So if a central angle was 20 degrees, the measure of its arc would also be 20 degrees. So if I were to know, as we are given here, that angle AOB, this central angle, was congruent to this central angle, I would therefore know that AB was congruent to XY by definition. Now let's take a look at if we knew the arcs were congruent. Well, if the arcs were congruent, therefore the angles would be congruent. So if I knew AB was congruent to XY, then angle AOB would be congruent to angle XOY. A very similar relationship exists between the central angles and the chords. If the central angles are congruent, then the chords are congruent. And conversely, literally, if the chords are congruent, then the central angles are congruent. Finally, there's a relationship between the arcs and the chords. If the arcs of a circle are congruent, then the chords intercepting them are congruent. And conversely, if the chords are congruent, then the arcs are congruent. So, to summarize this, in the same circle or in congruent circles, congruent arcs implies congruent chords and congruent central angles. Or congruent central angles implies congruent chords and congruent arcs. Or if you know the chords are congruent, therefore the arcs will be congruent and the central angles will be congruent. Once you get one congruency, you've got them all. All right, Ramblers, a couple of videos, or a couple of tutorials for you to conclude the video, and I hope this helped. Number 8 on page 455 causes trouble every year. And they want us to prove that the chord BD is congruent to chord AC. The trick is going to be to prove that the arcs are congruent. So since I'm given that chord AB is congruent to chord CD, that must mean that arc AB is congruent to arc CD. Now, by the reflexive property, I know that BC is congruent to itself. So by addition, arc AC is going to be congruent to arc BD. Now, as we just learned, if arcs are congruent, then chords are congruent. So therefore, AC is congruent to BD. And that leaves us having proved the conclusion. Okay, number 22 on page 457 always causes problems. So let's take a look at it. And I think really it's more a matter of vocabulary than anything else. You may remember from the beginning of the PowerPoint, the beginning of the video, that when they talk about the center of an arc, it refers to the center of a circle that the arc is drawn on. So let's take a look. It tells us that from point Q on circle P, an arc is drawn that contains point P, A, and B. So let's zoom in and take a look at what that means. Okay, that means that there is a circle, circle Q, that arc AB is a part of. And as such, AQ will be a radius, BQ is a radius, and PQ is a radius. So they're all congruent to each other. Let me just complete the circle here. Alright, now P is a circle in its own right, and PQ is a radius, as is PA, so that's congruent, and PB, that's congruent. So as you can see, both of these triangles are regular triangles, which makes them equilateral and equiangular. So the measure of arc AQB is equal to the measure of central angle APQ and BPQ. Since these are angles of two regular triangles, that's equal to 60 plus 60, so the measure of arc AQB equals 120. Okay, Ramblers, any questions? Bring them into class tomorrow. Thanks for watching.